Welcome to saitechinfo, dear UPSC, tnpsc, NEET and JEE aspirants and school and college students.
Interference. Interference can be defined as superposition of two waves that increases or decreases intensity at certain points. In some places it will result a positive interference. So positive interference that results bright spots, bright intensity. Negative interference that is called destructive interference, that will result dark spot, and that is why you are able to get an interference pattern. For example, let us consider this source S1 and this is source S2. So from these two different sources, the wave train, the light wave train travel and meet at certain point P, and that is the interference point. So S1, S2 are the different sources, but as far as possible they should be identical, but it would be very difficult to get such identical sources. We will be explaining about obtaining the identical sources later. Anyway, let me consider S1 and S2 are two different sources. P is the superposition point where these two wave trains meet. We used to call wave train. So S1P, S2P are the two wave trains. They meet at certain point P, where you may either get a positive interference, that is constructive interference that results bright spot, and or negative interference that is called destructive interference, and that will result dark spot. That depends on the phase change. For instance, this displacement of each wave can be represented by this equation. Displacement of the first wave, that is first wave train, can be represented as y1 is equal to a1 sine omega t, y2 is equal to a2 sine omega t plus phi, where y1, y2 are the displacements of these two wave trains. A1, A2 are the amplitudes. What do you mean by amplitude? Amplitude is also called wave height. Let me consider the wave like this, and A, B, C, D, E are the different phases. A, B, C, D are the different phases. Let me consider A is the starting phase, 0 in terms of angle, radian, and this is pi by 2 radian, that is 90 degree, and this is C, 180 degree, D, 270 degree, E, 360, and thereby it completes a circular motion. Are you able to follow this? So a wave motion can be converted into a circular motion like this. And let me represent the position A here. It goes in the anti-clockwise manner. B, C, D, and again here E. Done. So A is 90 degree, 0 degree, B is 90 degree, C is 180 degree, D is 270 degree, and again A, it comes back to A. Of course, it has completed one circle, so that is why it is 360 degree. Now, being a progressive wave, it may continue. So it means it adopts this next circular motion. So for one wave, it is nothing but a one circular motion, and its a total length traveled is nothing but the circumference here, that is 2 pi r, right? Okay. Now the B position is called the peak position, crest, and D is the trough, the minimum position. So what is the maximum displacement? That is amplitude. Are you able to follow? That is called wave height. And in fact, these waves can be projected like this. So there will be an upward vibration like this, and again, because being transverse vibration, it is vertically vibrating like this, and this is also vibrating like this. It vibrates like this, vibrates like this, vibrates like this. So all these are, we can call it Y, the displacement. But the maximum displacement is nothing but the amplitude, that is the wave height. Do you understand? And that is A1 of the first wave. Are you able to follow? Y is the general displacement from the neutral position to the either maximum side or minimum side. I hope now it is very clear. And what about omega? Omega is the angular frequency. For instance, you have got 0 degree here, and it tends to an angle theta. Okay, so this is theta, the angular displacement. What is theta? Angular displacement. So this angular displacement, how much angular displacement occurs in a given time, that is called angular velocity. So it is given as omega is equal to theta by t. This is known as angular velocity. Do you understand? Angular velocity. And this angular velocity can also be called angular frequency in this case. Do you know why? For example, see, that is, it takes almost a 2 pi r length, is it not? That is the circumference. Okay. So for taking one revolution, what is the time taken? Otherwise, in other words, in a given time, how many circular motions can take place? And similarly, this can be converted as wave. So in a given time, how many waves can be crossed at one point? And that is why it is called angular frequency also. Are you able to follow? So angular frequency is nothing but angular velocity. So in this case, why we use this term frequency? Because it being a progressive wave, it can create n number of waves in a given time, and that too through a point. That is called frequency. So it's called angular frequency. So omega is equal to theta by t. I hope now it's clear. And t, time taken. Okay. And phi is the phase difference. What is this phase difference? For example, I already explained about the A, B, C, D, E phases. Probably this S1 can meet at C, and S2 can have A position. So what is the phase difference? At C you have 180 degree, at A 0 degree, means phase difference is 180 degree. So likewise, you have to bring about the phase difference, phase changes. So that is indicated as phi. And phi, because we do not know at what stage these two sources have been started. Okay, so that is known as, probably it may have starting, it would have started from 0, it would have started from even 180 also, who knows, it would have started even from pi by 2. So that is starting phase, that is known as epoch, that is represented as phi naught. So phi naught is epoch, so you can call it epoch, that is phi naught. I hope now you should understand the meaning of epoch, right? Phi means phase difference, phase difference between these two waves. Okay, therefore omega is equal to angular frequency, that I already explained, and phi is nothing but phase difference. Now we are talking about the net displacement, total displacement. So let us have y. So this is the positive displacement. If we take this as a positive interference, so y1 plus y2. If it is negative, y1 minus y2. Got it? Interference. Maximum resultant amplitude is given by y is equal to y1 plus y2. Y represents the net displacement, y1, y2 the displacement of the respective wave trains. A max, that is the resultant amplitude with the maximum mode, that is maximum resultant amplitude A max, is given by the whole square root of a1 plus a2 the whole square. When the phase change, that is represented by phi, is equal to 0 plus or minus 2 pi plus or minus 4 pi. For example, when phi 1 is equal to 0, that is the phase of first wave, the phase of second wave is pi. So 0 minus pi is equal to minus pi. Similarly, pi minus pi is equal to 0, 2 pi minus pi is equal to pi, pi minus 2 pi is equal to minus pi, 0 minus 2 pi is equal to minus 2 pi, 2 pi minus 0 is equal to plus 2 pi. So when you are able to get the phase difference as 0, plus or minus 2 pi, plus or minus 4 pi, that indicates the maximum resultant amplitude, that is A max. Similarly, minimum resultant amplitude can be represented as A minimum, and the net displacement is y1 minus y2, that indicates the destructive interference. So A minimum is equal to the whole square root of a1 minus a2 the whole square, when the phase difference value is equal to plus or minus pi, plus or minus 3 pi, plus or minus 5 pi. It means when phase difference is in the even order of pi, then it is constructive, that is, that results A max. Whereas when the phase difference between the two wave trains, when they interfere with the plus or minus pi, plus or minus 3 pi, plus or minus 5 pi, that is odd number pi radians with the phase difference, then it results A minimum, that is minimum resultant amplitude, that is given by the whole square root of a1 minus a2 the whole square, right? So here you should try to understand the phase actually. For example, any progressive wave can be converted into a circular motion also. For instance, when let me consider wave 1 where 0 to pi by 2 to pi, then 1.5 pi, then 2 pi, and goes on like 3 pi, 4 pi, etc. So that is represented in circular motion as given in the diagram also. Okay.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.